Okay, so here's the different setting. We're going to look at the equation 3x times 1 minus x. And we're going to look at the equation y equals x.
Okay.
What sort of shape is this equation? Y equals 3x times 1 minus x.
That is a parabola.
That is a parabola. What are the roots of that parabola?
0 and 1.
Okay, 0 and 1. So here's x equals 0, here's x equals 1. That is a parabola. Looks like that. Y equals x is just a line going up at a 45-degree angle here, and it encounters this parabola. Somewhere there would be reasonably easy to figure out where that was, but we don't need to do that for now. Okay. I'm going to show you a way to find that point that works surprisingly well.
Alright.
This doesn't work all the time, but we're just going to choose a random point near it. Okay? So choose a random point on the parabola that's near it, but don't intentionally miss. Let's put it that way. So we're just going to take a guess at the solution. And this is what they did in the paper. They just took a guess at what the solution was.
So let's put it here.
Okay? So now we're on the parabola here.
Alright.
And now this is going to be, this is my y value. This is how high up I am now. And I want to turn that into an x value. How can I find the same how can I find the x value that's the same as this y value?
You can just you can flip them. You can say, you can reflect it over this line.
Well, yeah, I could. What is this line?
It's the line y equals x.
So what do I know if I go to that line?
So we know that y equals x on this line.
Okay, so draw a dashed line over to there. Okay. So that turns out to be the x value that's the same as this y value. So I take my y value as my first guess. Then I'm going to go over to y equals x. Now I'm going to go to the function now. Go to the function. Okay. That's my new guess. Now go over to the line y equals x. Go straight across to the line y equals x.
Here.
Yeah. Now go to the function. Now go to the line y equals x. Now go to the function. See what's happening?
We're sort of spiraling it toward it.
Yeah. So we didn't know anything about what this root was. We just sort of could look at a thing and get near it, but we didn't know for sure. But we did this amazing iteration process, and finish it off. See what happens.
So like you're just gonna go over, and then down, and then over to here, and then up, and then just spiral in.
Yeah. And what can you say about our various approximations for where the root was?
Well, there's this bounce between, here you sort of overshot it, then you undershot it, then you over, and then it just converges to it.
Okay. Yeah. Surprisingly, just by this absolutely simple operation, we seem to zero in to the actual solution we were looking for, even though we didn't even really know very much about what was happening here. Okay? So this doesn't always work, but this sort of, I don't know what to call it, a dynamical system approximation is what they're doing, and I'll show you in the paper where they did this to find some angles that they were looking for that described the trajectory of the satellite. But it was not a lot different than this very simple idea of taking an initial guess and looking at how you moved around. It's a little bit different, but it's not that different. And this is one that you can understand pretty easily.
Yeah.
All right. So let's go up and take a look at the graph of that ellipse, and let's take a look at this kind of approximation here.
All right.